is Mrs. Razan, and I'm going today to be solving October-November 2024 variant 3, which was the last paper for the 2024 session, which is then after the February-March session 25. Now let's start with the first question. The first question shows the list of substances which is manufactured by fermentation, where first of all fermentation is a reaction where we will have yeast with anaerobic reaction in the fermenter. We'll put yeast in the fermenter and we will have anaerobic reaction, which is the absence of oxygen with glucose, where the yeast will start producing by anaerobic respiration ethanol and carbon dioxide. Not to be confused with ethanoic acid, because ethanoic acid is also produced in the fermentation after oxidation happens. Alright, let's go to the next question. Is monoatomic. What is meant by the term monatomic? Monatomic means it has one atom. For example, helium, neon, any other group 8 noble gases. What about diatomic? We heard about diatomic. Diatomic means 2 atoms per a molecule. For example, hydrogen, chlorine, nitrogen, etc. These are diatomic molecules and these are monatomic. Group 8 is always monatomic. Next question is a reactant in photosynthesis. Alright. For the reaction of photosynthesis, not to be confused with respiration. Photosynthesis is when we react carbon dioxide with water to produce some glucose and oxygen, while respiration is where we react glucose, which is the opposite of photosynthesis, glucose with oxygen to give the product, which is carbon dioxide and water. Alright, next question is a solvent in the extraction of aluminium. Alright, the answer is cryolite type. If you look up here, there wouldn't be any other solvent suitable other than cryolite type. Why cryolite? Cryolite lowers melting point of aluminium oxide. It also increases conductivity of the solution, so that when it increases conductivity, ions will be able to conduct more electricity for the cathode, for the anode, for the extraction of aluminium. Alright, name an ore of iron. The iron ore has hematite. This should be learned. What about aluminium? Aluminium ore called bauxite. We also have other ores, but these two are the only ones you need to learn. Hematite and bauxite. Is manufactured from methane, hydrogen. This is the reaction of the steam reforming, where we react methane with steam, where we produce carbon dioxide and hydrogen, where we react methane with water, carbon monoxide and hydrogen. Alright, let's go down. A compound with giant covalent structure, which is silicon dioxide. First, let's look at the substances they gave us. We have bauxite, carbon dioxide, cryolite and other substances. The ones with covalent structures are carbon dioxide, ethane, ethanol, ethene, graphite. Helium is monatomic, so it doesn't have any covalent bond. Hematite, hydrogen, silicon, IV oxide. Alright, the ones with giant covalent structures is silicon IV oxide. Alright, so if we look here, carbon dioxide, ethene, ethanol, ethene are simple covalent compounds, but the ones that are giant covalent compounds, graphite and silicon IV oxide. You have to remember that we also have diamond, which is also a giant covalent compound with a similar structure to silicon IV oxide. Alright, let's go down to the next question. Is used as a lubricant, graphite. Lubricant means something like a pencil, something that will slide off or right, or in terms of general meaning, it's something that will make something slimy, or let's say it will give an object less friction upon movement, anything like that. So graphite is a lubricant because we use it actually in pencils. When we use it in pencils, we use it to write, so technically it's a lubricant. Alright, next question is tested with lime water. Or lime water is calcium hydroxide. Calcium hydroxide will react with carbon dioxide to give us calcium carbonate. Calcium carbonate, so calcium hydroxide is colorless substance, colorless solution. When we add carbon dioxide, we bubble it through the solution, it will become cloudy. That cloudy color is calcium carbonate. This is a test for carbon dioxide gas, because if carbon dioxide reacts with calcium carbonate, it will produce calcium hydroxide, it will react to produce calcium carbonate. State the meaning of the term electrolysis. Generally, if you took electrolysis, you will know that we take ionic compounds, not covalent, not metallic, only ionic. We break them down with electricity. The meaning of electrolysis is breaking down ionic compounds in molten or aqueous, so that the ions are free to move using electricity. Yes, we use electrons, electrical energy in electrolysis and convert it to chemical. Ionic compounds are only used because they have positive and negative ions. They are molten or aqueous. In that way, the ions are free to move, so that they conduct electricity. Alright, so this question we have about electrolysis. So we have anode and we have cathode. We know that anode is positive, cathode is negative. We know that in electrolysis, anode attracts negative ions, cathode attracts positive ions. But let's look here. We have the electrolyte. Electrolyte is the solution we have in the electrolysis. Okay, the solution here, or the liquid, is concentrated aqueous potassium iodide. Okay, let's draw the ions. Concentrated aqueous potassium iodide means it has water, so we have OH ion and H plus ion. We have also potassium, as it said here, and we have iodide ion, as it said here. But it is concentrated, so which ions will we choose? First of all, this will be the cathode side. Cathode takes the least reactive, we will take hydrogen. Anode takes the most concentrated, so it will be the iodine. We need to remember in electrolysis about the rules of the anode and the cathode. We also need to remember this observation. In the anode, we took the iodine, not the iodide, because iodide is the ion, iodine is the element. The product will be produced iodine solid or iodine solution. The color of the solution will become brown because this is the color of iodine in solution. Normally iodine is a solid, but do not confuse in the solution. Cathode. Now the cathode, we have here the hydrogen, and we have to remember we will produce bubbles of colorless gas, which is the observation for hydrogen, because hydrogen is colorless. Do not forget to learn how to do equations for each of these reactions. Iodine will lose electrons. Hydrogen will gain electrons when doing the ionic half equation. Okay. Lastly, we have here aqueous copper sulfate. It's easy. We will have here copper, hydrogen, copper, hydrogen. We will have also sulfate ion and hydroxide ion. Which ions will we take? First of all, cathode, we will take the least reactive, which is always a copper. Copper is less reactive than the hydrogen. What about the sulfate and hydroxide? Here it said aqueous solution. It didn't say dilute or it didn't say concentrated. But personally, we will take the hydroxide ion because sulfate ions, nitrates, and phosphates, any complex ion cannot be taken by the anode. So we only focus on ions such as hydroxide, or maybe مثلا iodine, chlorine, sulfide, any normal ions, not complex ions. We also need to remember the half ionic equation for the hydroxide, which will produce water and oxygen. As said here, it will produce oxygen. Bubbles of colorless gas are seen. Now, for the cathode, copper will be produced, which will be a solid. The color of the copper will be pink, brown. Next question here. Oxygen is produced at the anode by the Clausius equation of copper to sulfate. Write the half ionic equation. Hydroxide ion produces water, oxygen, but loses 4 electrons. How do we know it loses 4 electrons? By balancing. Here we have 4 hydrogen, so we will do 4. 4 multiplied by charge will give us 4 electrons. I recommend this equation you try to learn it and remember it at the same time. Next question we will have: aqueous copper 2 sulfate is electrolyzed using copper electrodes instead of graphite. If we use copper, we need to remember actually we use graphite because it is unreactive and it will not get involved in the electrolysis. Copper electrodes, it will react with the electrolysis. It will, for example, the anode will deposit ion while the cathode will take up the ions. And it said here, explain why the mass of the anode decreases during the electrolysis. Copper ions are deposited from it. Yes, the copper ions are removed from the anode because the copper ions are reactive and they will be the ones losing electrons and becoming ions. This is a rule that will be remembered about the anode if we use metal electrodes, not necessarily copper. We can use zinc, iron, any metal electrode that is reactive will lose ions. Name the product formed as a cathode. It will be copper. It will be copper because the reason we see copper in the cathode, it will take up copper ions from the anode. It will not take it from the solution. This should be remembered. That's why the solution colored is not changed. When it's said here, state what change, if any, is observed in the appearance of the aqueous copper 2 sulfate, we will say no change. Why no change? Because the cathode takes the copper ions from the anode, not from the solution. So the rate of the ions getting deposited from the anode is the same as the rate of ions getting taken from cathode. That's why there is no change for the current solution. Let's go down. Here we have a question and it said tin oxide has a formula tin oxide. The formula mass of tin oxide is 151. Calculate the percentage by mass of tin oxide. Okay, this is easy. When he says percentage by mass of tin, for example, he would say percentage of nitrogen by mass in nitrogen oxide or any other substance. What will we do here? We will take the metal we have here, or it doesn't necessarily be a metal or non-metal. We will take its mass from the periodic table, the mass number, or let's say the nucleon number. Here it turns out that tin has 119 mass number. We will then divide by 151, multiply 100. The answer turned out to be 78%. If we have any decimals, we would write it. If he said write the answer to 1 decimal point, but it looks like he focuses on writing a whole number. Right, let's go down. Tin oxide is amphoteric. Tin reacts with aqueous sodium hydroxide to form a salt and water. Only the salt contains a negative ion with the formula tin oxide 3 minus 2. Okay, good. State the meaning of the term atmospheric. Atmospheric means amphoteric, Amphoteric, it reacts with both acid and a base. It will neutralize both of them. It will produce salt and water in both of them. So amphoteric will produce salt and water with acid and a base, and it will neutralize both of them, unlike acid reacting only with a base and base reacting only with the acid. Write the symbol for the equation between tin oxide and sodium hydroxide. Okay, so first of all he said we will have tin oxide with sodium hydroxide. Okay, normal. How about the salt that we will form? What will be the formula of the salt we will form? Okay, so we have this formula of tin. He said the salt will have this formula, and he said we will produce also water. Well, what about the sodium ion? What about the positive sodium ion? It's easy. We will add only sodium tin oxide 2. So we will pretend that tin ion, the complex ion, is an ion that will react with sodium, and we will only just display the charges. Sodium is positive 1, tin O3 minus 2, we will displace it, and it will turn out like this. Yeah, so the equation will turn out like this. Tin is a metal that forms both covalent and ionic compounds. So just why this is unusual for a metal. Alright, you know, metal only react with non-metal to form ionic. Non-metal with another non-metal, you give us covalent. What about this one? This one reacts with both metal to form ionic, non-metal, covalent. The metal should only react with a non-metal to form ionic compound. It shouldn't be completely making a covalent compound, as covalent compound is only non-metal and non-metal. Here we have a dot cross diagram, and he said for us to complete the outer shell electrons. In these types of compounds, first of all, they will be covalent compounds only. How did we know they're covalent? Metal and non-metals react together to share electrons. They do not give or take, they only share electrons. Anyways, here we find that chlorine has 7 electrons of its own, as we see from the x's belong to chlorine, and the cross or the dash belongs to sulfur. Is in group 4, as it said here, is covalent, and tin has 4 electrons in its outer shell. Alright, tin has 4 electrons in its outer shell, so it will react with the chlorine to give each one of them 1 electron type. Why does it give 1 electron to each one of them? Because the chlorines need to have a full outer shell, and in order to have a full outer shell they will need 8 electrons, so they will share 1 electron each. Tin also needs 1 electron from each chlorine. With its 4 electrons it has, 4 plus 4, it will have 8 electrons, which is a full outer shell for tin. Remember, this is about only the outer shell electron while sharing the electrons. We got down here to a question about bonding. The melting point of tin chloride and tin oxide are shown. Tin oxide melting. Alright, as we see here, tin oxide has more melting point than tin chloride. Okay, so let's assume tin chloride is covalent and tin oxide is ionic. We know what type of bonding is ionic contains, صح? Electrostatic forces, which is forces between positive and negative ions, which exist only in ionic and also in metallic. While tin chloride is covalent, so it has covalent bonds, and between the covalent bonds between these molecules, between them there is intermolecular forces between the molecules, which are weaker. As it said here, tin chloride is ionic. It has electrostatic forces of attraction between positive and negative ions that are strong. When we say strong, we say it takes a lot of energy to break. So that's why it has a high melting point. Covalent compounds such as tin chloride has weak intermolecular forces between molecules. Remember, not covalent forces. A lot of you are confused between covalent and intermolecular forces. Covalent is between 2 molecules. No, not 2 molecules, 2 atoms. Covalent is between 2 atoms, for example, carbon atom. But intermolecular is between, for example, we have here several molecules of carbon. The bonding between the molecules is intermolecular, not the covalent, which are weak forces that require low amount of energy to break. Now here we have a question. Magnesium, aluminum, tin and copper react with each other. When aluminium foil is added to the aqueous tin 2 sulfate, a reaction does not occur even though tin is above aluminum is above tin in the reactivity series. So what he's saying here is that aluminum is more reactive than tin. When we add aluminum to the tin, it doesn't react. Why? Aluminum has oxide layer. What does this mean? When we have aluminum naturally will form oxide layer, and the layer of the solid will be made of aluminum oxide. Yani here we will have aluminum, from the outside we will have aluminum oxide layer. Alright, this oxide layer is unreactive and it will prevent the aluminum from reacting with any other substance. Let's go down. Aqueous solution of tin sulfate contains tin 2 ions. We have several experiments carried out. Alright, this is a reactivity question. Experiment 1. Copper is added to tin 2 sulfate. Alright, copper is lower reactivity than tin. So will it react if it's added to tin sulfate? Can it react? Can it displace the tin? No. Reactivity series is all about displacement. When we, for example, we have A reacting with BC. If A is more reactive than B, it will take the place of B. Copper is less reactive, so no reaction will be carried out. No reaction. What about magnesium? Magnesium is added to tin sulfate solution. Look, magnesium more reactive than tin. It will react and it will give us magnesium sulfate, which we did the ionic equation. So it will give us Mg plus 2, which is the charge of magnesium plus tin. It will looks like the charge of tin went to magnesium, when what happened is that the magnesium only displaced the tin from the reaction. طيب. State what is meant by the term hydrated. He said here hydrated tin nitrate decomposes when heated. Okay, we know that crystals when we heat them they decompose and become powder, يعني dehydrated or anhydrous we can say. State what is meant by the term hydrated. When we say hydrated in terms of crystals, hydrated copper sulfate, hydrated copper nitrate, we say that this crystal has water in the compound, or let's say has water of crystallization. Has water of crystallization. If a compound it's said hydrated, it means it has water of crystallization like this inside of the compound. Inside of the crystals there will be water, not from the outside, from inside the compound, fully bonded. Next question. So let's balance this equation. We put the elements. Here we see we have 2 tin, and here we have 2 nitrogen. Here we have 2 multiplied by 2, we have 4 nitrogen. Also here we have 4 oxygen. Let's see, be careful with oxygen because oxygen is in multiple compounds. Here we have 2 multiplied by 2 multiplied by 3, which is 12 plus 2 multiplied by 20, which is 40. We have 12 plus 40 of oxygen, which will give us 52. This will give us 52 oxygen. What about here? We have 2 oxygen plus 8 plus 2 oxygen plus 40, same exact number, it will give us here 52. Then last thing, the hydrogen. We only do 2 multiplied by 20 multiply again by 2 multiplied by 2 4 multiplied by 20, this will give us 80. Is here the same thing, here will give us 40 multiplied by 2, same thing, it will become 80. Alright, so we solved the balancing. Let's go down. The question is about sulfuric acid. Dilute sulfuric acid and aqueous sodium hydroxide can be used to prepare sodium sulfate crystals using this method that involves titration. Cymophysylene is used as an indicator for this titration. State the color change of cymophysylene at the end of the titration. Okay. He said he added cymophysylene. We know cymophysylene is completely colorless in acid, in neutral substances. It's completely colorless. But in alkali, it will be blue. Here in the flask, we have sodium hydroxide. And then we added cymophysylene. So the color will be blue. When we add the acid to the exact amount, it will become colorless. How do we know it's neutralized? Because it became colorless. And that's the color for neutral. From blue to colorless. Same thing with phenolphthalein. Phenolphthalein, instead of blue, is pink. So that's why the universal indicator is not used for this titration. It has a range of colors. Alright, so universal indicator, for example, goes from red, orange, to yellow, to green, to blue, and then from blue to violet. This is a very large range of colors, and the color can be depicted differently from one person to another. One person can see light green, another person can see light yellow. The colors will be different for each person, so it's better to use smaller range color indicators. Cymophthalein, phenolphthalein, methyl orange. Any of these work. Let's continue working. Here we have a question about titration. We have volume of sodium hydroxide. Alright, let's see here, right volume. Concentration. We also have a volume of dilute sulfuric acid. We have the reaction equation. Calculate the concentration of sulfuric acid. So first of all, let's look at the steps they give us. Calculate the moles of sodium hydroxide used. If we have volume and we have concentration, how do we find the moles? We use the rule mole equal volume multiplied by concentration. Volume should be in decimeter. How do we convert from centimeter to decimeter? We divide by 1000. Look here, we did divide by 1000, 25 divided by 1000, multiply 0.1. This will give us 2.5 multiplied 10 to the power of minus 3. Alright, next one. Determine the number of moles of sulfuric acid that react with the sodium hydroxide. Alright, this is simple. We have the mole of the sodium hydroxide. 2 to 1. 2 to 1 ratio. We do not have the mole of the sulfuric acid, so we cross multiply. Divided by 2, and we got the answer. 1.25 multiplied 10 to the power of minus 3. Calculate the concentration of the sulfuric acid. It's easy. We have mole. We have volume. We do not have concentration, so we will reverse the equation. Concentration is equal to mole over decimeter cube. Mole over volume. Mole divided by the volume. He gives us the volume in centimeter. We will convert it to decimeter cube. And this is the final answer. Now let's go down. As this is provided with aqueous solution of sodium sulfate, describe how to prepare a pure sample of sodium sulfate crystals from the solution. Let me show you. We have a solution of sodium sulfate. Alright? We want to turn it to crystals. Alright. When we say solutions means a mix of the soluble solid and water. So this water has particles of sodium sulfate. We will heat. So we will go forward, which is exothermic. Alright. The pressure of the colloidal system is then increased. Okay. We know that the rules of pressure applies to the moles of gas. This side we have 3 moles of gas. How did we know? 2 plus 1. Here we have 2 moles of gas. So 3 and 2. The pressure, if the pressure increases, we want to lower the pressure, so we will go, for example, to the side with less moles, not the side with more moles, because we will have less pressure, so we will go, for example, forward. Anyways, let's continue. State the direction in which the position of the equilibrium shift. Explain your direction. We will go forward, like I explained earlier. Explanation: we have few moles of gas. You can say fewer molecules of gas, fewer amounts of gas, but I recommend saying fewer moles of gas. This question is about hydrocarbons. State the meaning of the term hydrocarbon. Anything that contains hydrogen and carbon only is a hydrocarbon. For example, methane, ethane. Glucose is not a hydrocarbon, it contains oxygen. So yeah, you get the picture. Alkenes, carbon and hydrogen only. Alkyne, for example, methyl, hydrocarbon. Propane can be made from the long chain alkenes such as dodecane. Dodecane contains 12 carbon atoms. So propene can be made from a long chain alkene of 12 carbon atoms. And we know dodecane is an alkane from the name dodecane, which is ANE. One more thing they said it has 12 carbons. Now they said to deduce the formula of the dodecane. How do we deduce the formula? What is the general formula of all alkanes? It is CnH2n plus 2. So you get the picture. 12 with 12 multiplied by 2, which will be 24 plus 2. So we got 26. Alright. The type of reaction in which we take long chain alkanes and convert it to smaller particles is called cracking. Sometimes people confuse this with steam reforming, even though this has nothing to do with steam reforming. Steam reforming is only methane with some steam. This is only cracking, taking long chain of alkane to small alkane chains. And also this reaction is confused with fractional distillation. In my opinion, this reaction only happens after fractional distillation of petroleum. Alright, let's go down and look at the next question. Propene is an unsaturated hydrocarbon. Propene reacts with bromine. State the meaning of the term unsaturated. Unsaturated means carbon-carbon double bond in alkene. Remember, in alkene. For people who get confused or can't make the difference, unsaturated, when you see un, it means double carbon-carbon bond. When you see saturated, it means alkane or any other compound that has carbon-carbon single bond. You'll write the molecular formula of the product formed when propene reacts with bromine. Here is the product, but let's do the reaction. Propene looks like this. Alright, don't forget that in alkene you will have to differentiate in the naming system, because the place at which the carbon double bond falls on, it will have a number on the name. For example, this will be propanene. Alright, here we have hydrogen, and a hydrogen. Alright, when this compound reacts, it will break down the double bond and it will start taking in any other compound. It will react with bromine, so the bromine will take the empty place and it will place it, for example, here or here. So now we have dibromo. The bromo is in carbon number 1 and 2, so 1, 2 dibromo propane, like this one. Let's go down. Here we have the molecular formula of styrene. Okay, we have a styrene molecule, never seen it before. Determine the empirical formula of styrene. C8H8. This question is in 1 mark. Okay, if it's 1 mark, we could say easily that the question only requires dividing. C8H8. It's obvious that we will divide by 8 to give us the simplest ratio of styrene. For example, if it would give at CH2H4, we will only divide by 2 to give us CH2. Alright. Here it says here styrene can be polymerized to polystyrene. Remember, styrene is alkene. State the type of polymerization that occur when styrene is converted to polystyrene. Addition. A lot of people get confused about polymerization. We have 2 types of polymerization. We have condensation polymerization and we have addition. Addition is when we have alkene. Condensation is when we have, for example, carboxylic acid, alcohol, dicarboxylic, any reactions that removes water. Here in the addition reaction, we only remove and break down the double bond. Alright, he wants us now draw the structure of 1 repeat unit of polystyrene. He said 1 repeat unit. Include all of the atoms and all of the bonds. The C6H5 group would be represented as C6H5. Okay. The last word he meant here that we wouldn't change the C6H5 because some people would write it like this. No, he wants you only to write it as a molecular formula. Alright. So let's compare the formula of the compound with the one we drew here. We only break down the double bond we had in polystyrene. So all of the hydrogen are in the same place, so we didn't replace the C6H5. And no, you can't write the C6H5 in this place, because if you write it here, it will count as wrong. And if you place the C6H5 down and you put the hydrogen up, it will still count, right? Now here I will draw the extension bonds, which shows that it is continuous and will not stop repeating, or it will stop repeating but it is repeating. N means we have a number of bonds, a number of the molecule of polystyrene. Like this, we finished our past paper / trail session for the 2024 October-November. I hope you understand this paper, and if you have any question, leave a comment.